NASA's Voyager spacecraft are humanity's most distant emissaries. Credit NASA. Caltech. Paul Sutter is an astrophysicist at The Ohio State University and the chief scientist at COSI Science Center. Sutter is also host of Ask a Spaceman and Space Radio, and leads astro tours around the world. Sutter contributed this article to Space.com's Expert Voices Opt-Insights. It must be lonely traveling out beyond the edge of the solar system, at points so distant that the sun is just another point of light, still brilliant, but without shape. As the years go by and the kilometers add up, the sun, too, fades into the background, just one of the multitude of stars in our. It's almost inconceivable two small spacecraft, each no bigger than a car, furnished here on Earth and flung into the depths. Their mission's nearly over, their power supplies almost exhausted. Their ultimate fate's to wander the vast expanses of the Milky Way alone. The Voyager missions, launched in the late 1970s, are now the furthest flung emissaries of humanity. Here is a recounting of their travels so far, and what the future has in store for them. 5 facts about NASA's far-flung Voyager spacecraft. It was perfectly timed. Just a couple decades after we first developed the technology to launch interplanetary space probes, equip them with cameras and other scientific instruments, and remotely communicate with them, the planets aligned. Usually, that phrase is relegated to meaningless astrological positions, but this time it meant something seriously scientific. About every 200 years, the outer planets of our solar system, Jupiter, Saturn, Uranus and Neptune, wind up on the same side of the Sun, making it possible for a single swift spacecraft to visit all of them in one go. That's important, because when something is launched to the edge of the solar system at tens of thousands of miles per hour, it's not exactly going to come back home. Alignment occurred most recently in the 1970s and 80s, enabling the breakthrough Voyager missions. The twin spacecraft those were the days when NASA could build two of everything, were packed with the latest observational gear, far surpassing the capabilities of the earlier Pioneer probes. The scientific return from those two craft is almost immeasurable. Detailed images of the cloud tops of Jupiter, analyses of the rings of Saturn, magnetic field measurements, cosmic ray detections, an unprecedented close-up view of the giants of our solar system. After 1989, the Voyager probe's primary mission was over. The most distant of the siblings, Voyager 1, now sits 13 billion miles 21 billion kilometers from the Sun. That's 140 times greater than the Earth's distance, for those of you keeping score. On August 25, 2012, Voyager 1 reached a new milestone. It became the first human-made object to truly exit the solar system. While there are a few definitions of the boundary to interstellar space, the one used by NASA makes enough sense. The hazy bubble layer where the high-energy particles emitted by the Sun, the solar wind, mix and mingle with the general galactic milieu. After that momentous event, Voyager 1 is now adrift between the stars. Light years of essentially nothing between it and, well, nothing else. In about 300 years, the craft will reach the inner boundary of the Oort cloud, the thin, diffused shell of frozen debris left over from the formation of the solar system. Voyager 1 will eventually come within 1.6 light-years of the star Gliese 445. In astronomical terms, this will be a near-miss. But don't hold your breath. The encounter, for lack of a better term, won't occur for another 40,000 years. After that, it gets a little difficult to predict Voyager's journey, as chaotic motions within them make accurate predictions of stellar movements challenging. But given the wide swaths of empty space between the stars, the spacecraft's visit near Gliese 445 is probably the closest that Voyager 1 will approach another star, ever. In 200 million years, the lonely spacecraft will complete its first circumnavigation of our. The Voyager spacecraft carry more than just scientific instruments, which will be rendered useless in a few more years. Their radioisotope thermoelectric generators, powered by piles of radioactive plutonium, will soon exhaust themselves. Tucked between those instruments, bolted to the exterior of each spacecraft, is a small golden disk. Etched into that disk are diagrams showing the location of the Sun relative to nearby known, flashing, dense cores of stars called pulsars, representations of the hydrogen atom, and instructions. Following the pictograms, one could, it's hoped, construct a spinning platform and a stylus, spinning the disk to interpret the vibrations in the stylus as sound waves. That is, an alien could play the record. Dear E.T. Math on Voyager's golden record tells a story. Those sound waves carry raw information, but also recordings of sounds from here on Earth, voices, nature, and music from around the world. The record was designed by a committee led by Carl Sagan, a scientist and legendary science communicator, and Frank Drake, an astronomer whose famous equation purports to estimate the odds of finding extraterrestrial life. The record is intended to be an everlasting emissary of Earth, a thin slice of what humanity is. Sure, this golden record will outlive its creators, and maybe even us as a species. It's a bold and noble effort. But it's to fail, except as a symbol. Interstellar space is just that, space. There's an incredible amount of open room between the denizens of our. Heck, even 1.6 light-years is considered a brief stroll in these contexts. Add to that the extreme rarity of life, and the Voyager probes are almost certainly fated to touch nothing but microscopic interstellar dust for billions of years, or even for eternity. So bold and noble, but also futile and narcissistic. Perhaps it does reflect our species after all. Learn more by listening to the episode What Fate Awaits the Voyagers, on the Ask a Spaceman podcast, available on iTunes and on the web at http://www.askaspaceman.com. Thanks to Rob H. and Ryan S. for the questions that led to this piece. Ask your own question on Twitter using Ask a Spaceman, or by following Paul at Paul Matt Sutter and Facebook.com Paul Matt Sutter. Follow us at space.com, Facebook and Google. Original article on space.com.